The first special type of sequence and series we're going to talk about is arithmetic. So what that means is you have a special sequence where the difference of any two consecutive terms is constant. So if you look at the n plus 1 term minus the term right before it, it's going to be a constant, which we're going to call d. So this d is going to be the common difference, hence d. So each term in your sequence is going to be found by adding that common difference to the previous one. So you technically have a recursive definition for this sequence. But you're going to see we are able to write an explicit formula for this as well. So let's go ahead and determine if the sequence is arithmetic. If so, we want to find that common difference d. So we've got the sequence 3, 7, 11, 15, 19, and the dots tell us that pattern continues on forever. So if you look at the second term minus the first, their difference is going to be 4. If you look at the second or third minus the second, it's 11 minus 7, that difference is 4. Fourth term minus the third term is 15 minus 11, that difference is also 4. Fifth term minus the fourth, that difference is 4. So the difference between each consecutive terms is 4, so this is going to be an arithmetic sequence because those dots tell you the pattern continues. If we look at this next one, you might be able to immediately spot there's not the same type of thing going on. If I look at the second term minus the first, 60 minus 120, negative 60. Third minus the second gives me negative 30. So the difference is not the same, so I cannot say the sequence is arithmetic. It's actually going to be a special type if you notice it's getting halved each time. So you're multiplying to get your next term. So let's actually come up with a pattern for that general term. So this way, if I want the millionth term, I do not need to find everything before it. So I'm going to start with my first term that has to be given, A1. My second term is my previous term plus that common difference. My third term is the previous term, which is A2, plus the common difference. But A2, I can write in terms of A1. So this is equal to A1 plus D plus this other value of D. So we're replacing the value of A2 from that prior step. So really, you've got D plus D. This is A1 plus 2D. If you look at the fourth one, it's going to be the third term plus that common difference. And same type of thing again, the third term is A1 plus 2D. So you're going to replace A3 by that formula. And then you're adding another D, so you really have A1 plus 3D. So if we go ahead and look to see a pattern going on, all you're doing is changing the value of D. And all that value is in front of it is 1 less than the prior term. So your general term AN is you start with the first term and you add n minus 1 times d. And this really holds for any value of n, because if you plug in n equals 1, this will be 0, and it just lands you at A1. So this is our explicit formula for the arithmetic sequence. Okay. So let's go ahead now, given that general formula, we want to find those first 2 terms, or first 4 terms, and determine if it's arithmetic or not. If it is, we're going to find the common difference. So this is going to be a little bit different than the prior example because just picking a couple values of A isn't going to prove it's arithmetic. But I'm going to go ahead and find those first 4 terms first. So A1, replace n by 1 to give you 3 minus 10, so this is negative 7. A2 would be 3 times 2 minus 10, which is negative 4. A3 would be 3 times 3, or 9, minus 10. That's negative 1. And the fourth term is 3 times 4 minus 10, or 2. So if you notice, to get from one term to the next, it looks like we're going ahead and adding 3. So it seems like the common difference is 3, but how do we guarantee it holds for every 2 consecutive terms? So back up here, this one was a little bit different. So the dots tell you to continue on forever with this same pattern. But here, I'm just given that term. I don't know that it's going to continue on forever, and I can't feasibly test that. So what I want to do is go back to that formal definition. I want to look at the nth term, and I want to look at the n plus 1 term. The difference between these better be constant. So if you want the n plus 1 term, just replace this by n plus 1. So that'll be 3n plus 3 minus 10, or 3n minus 7. So now if I look at the difference between any two consecutive terms, the n plus 1 term is this, subtracting the nth term gives us 3n minus 7 minus 3n plus 10. So the 3n's end up canceling. Negative 7 plus 10 is 3. So this holds true for all n. The difference between any two consecutive terms is 3. So it is an arithmetic sequence with a common difference of 3. Okay? So this is your way to actually prove it's arithmetic. So now let's work on finding some sequences given some certain properties. So we're going to be given different pieces of information, kind of have to reverse engineer what's going on. So I know A1 is equal to 6, D is equal to negative 2. So if I want my nth term, it's the first term plus n minus 1 times D. First term is 6, D is negative 2, so I keep the n minus 1, replace the D by negative 2. If you distribute that negative 2, we're going to end up with the general term being 8 minus 2n. So now let's go ahead and find the 19th term of the sequence, and they're told that it's arithmetic. So this pattern is going to continue on forever. I surely don't want to go through and find all of the other terms that are missing. Instead, what I'm going to do is utilize that it's arithmetic, find the common difference, and find my value of A1, which is just the first term, 7. Because it's arithmetic, I just look at the difference between the two. So at two consecutive terms, 1 minus the term before it, which is 7. My common difference is negative 6. So I'm going to subtract 6 each time to get to those next terms. So now I can write my formula for an by replacing my value of a and my value of a1 and my value of d. Going ahead and simplifying it, my nth term would be given by 13 minus 6n. So if you want the 19th term, you're going to go ahead and just plug in 19, and you'll see this is equal to negative 101. So don't sit there and find, now that you've got the first 4, the 5th, the 6th, the 7th, the 8th, don't do that. Just find that general term instead. So let's do another example. We're going to be given the 9th term and the 15th term, and we're going to have to reverse engineer and figure out what the nth term is going to be. So we're told the 9th is equal to negative 5, the 15th is 31. So knowing that, I'm going to write the formulas we have for the 9th and 15th term of any arithmetic sequences, because I don't know what A1 is and I don't know what D is, but I can reverse engineer from that general form for any arithmetic sequence. So my 9th term is the first one plus 9 minus 1 times the common difference. So my 9th term has to equal A1 plus 8D. Well, I know that my output is negative 5. So I get the equation A1 plus 8D is equal to negative 5. So I've still got 2 unknowns, but that's okay, because I can do the same thing with my 15th term. My 15th term is A1 plus 15 minus 1D, which is A1 plus 14D. And I know my 15th term is 31, so 31 better equal 8,1 plus 4D. So what we really end up with here is a system of equations, and we just need to solve that to figure out A1 and D, and that gives us our general term. So I'm going to go ahead and work with this system, solve it by elimination or substitution. It's going to be much easier to go ahead and just eliminate that A1 variable, so I'm going to just multiply the top by negative 1. And that's going to give us negative A1 minus 8D is positive 5. The second equation doesn't stay, or stays the same. When we add these together, the A1s cancel, and we get 6D is 36. So now I know my common difference is 6. Now I can utilize this in either equation to find A1. So I'm going to go ahead and just use the first one, plug in that D is equal to 6. And so we get A1 plus 48 equals negative 5. So my value of A1 is negative 53. So I've got the two pieces I need to actually write that general term. You get A1 plus n minus 1D. So the nth term is going to be negative 53 plus 6n minus 6. So the nth term is 6n minus 59. And you can go ahead and check your answer by plugging in 9 and plugging in 15 and making sure you get those same values that were given to us back. So now we're going to go ahead and we're going to sum up this arithmetic sequence to get an arithmetic series. So the sum of the first n terms is called a finite arithmetic series, and it's going to be given by the following formula. If you want to sum up the first n terms, it's a sum from I equals 1 to n. You've got that general term being the A1 plus n minus 1D. You can actually show this is equal to the number of terms over 2 times the sum of the first and last terms, where the n is greater than or equal to 2. So the key is this has to be finite. If it's not finite, you can't use this formula. So you cannot sum up from I equals 1 to infinity. And the index has to start at 1. If it doesn't, you've got to do something else. And we'll see an example like that. So the index must start at 1. So we have another formula that's going to help us out in the case that it doesn't start at 1, or that I don't know what my first or last term is. So the second method we have is that summing up the first n terms will be equal to n over 2 times 2a1 plus n minus 1d. So the second method is going to be useful when you don't know that last term, like here, or I have another index other than 1. So I can use this second method instead. So let's find the sum of this arithmetic sequence, which becomes that arithmetic series. So we've got from I equals 1 to 18 of 3i minus 10. So kind of comparing the two, the index starts at 1, so we're good. The value up here is my value of n. So here n is equal to 18. I need the first term and I need the last term. So my last term is a18. You plug in I equals 18 to get 44. And you need your first term, so you plug in I equals 1. Your first term is negative 7. So if you want this sum of this arithmetic sequence, it's going to be n over 2 times the sum of the first and last terms. So this will equal 333. So you can see it's going to be very tedious if you go through and try to do this by hand. So now let's try to find the first term and the common difference d for this arithmetic series, knowing that the sum of the first 20 terms is 1090 and the 20th term is 102. So the first thing I can do is I can utilize my formula for Sn to find my first term. I'm dealing with 20 terms here, and I've got all of these pieces, so I can figure out what A1 has to be. So when you replace n by 20, you get S20 is 20 over 2 times A1 plus A20. So plugging in what we know, S20 is 1090, n is 20, and A20 is 102. So now I can go ahead and solve this equation for A1. That gives us 1090 is equal to 10 times A1 plus 102. You can distribute that 10, subtract the 1020, and we get that the first term is going to equal 7. But I still need to figure out what that value of d is. But I can go ahead and use this piece of information. So we still need to find d. You know A1 is equal to 7. You know A20 is 102. But the 20th term is A1 plus n minus 1d. So we figured out already what A1 is equal to. So the only unknown in this equation now is D. So going through and solving for that, we end up with D equals 5. Okay. So it's all about utilizing these different formulas we have with those pieces of information that you're searching for to figure out which one can I solve explicitly. So let's go through this example now. Like I said, when we've got a sum that starts at something other than 1. So we've got a bit of a problem here. I just can't use that formula n over 2 times the first and last term. So it's going to be a little bit confusing because that index starts at 3. So the first thing I'm going to do is I'm going to plug in k equals 3, k equals 4, and k equals 5. So we know it is arithmetic, so this is going to help us out a little bit. You plug in 3, plug in 4, plug in 5, you're going to get these different values. So you can think of your first term really just being the first term that appears here. And that common difference to get from one term to the next would be subtracting 3. So here, your first term, which is our A1, even though I know we plugged in k equals 3, is going to be -5. And your value of D is -3. So we're going to utilize that second formula because, again, that's going to be helpful when the index is something other than 1. The only tough thing we have to figure out is what is this value of n, because that's basically the number of terms we're dealing with here. I'm good on this piece and I'm good on this piece. So all we need is going to be n. Now, if you think of this, if we summed from k equals 1 to 9, you would have 9 terms. That would be your value of n. But since we're starting at k equals 3, we're ultimately missing 2 terms. We're missing k equals 1 and k equals 2. So your value of n is 7. So now I can just plug in 7 for my value of n. So this sum will be 7 over 2, 2a1, which is the first term we had, -5, plus 7 minus 1 times d. That's equal to 7 over 2, -10 minus 8. And if you do that, it'll equal -98. Okay? So that's probably the hardest thing, finding that value of n. It might seem kind of natural for you to want to subtract these two values, but really you get one more than that. So just think, what am I starting at? How many am I missing from that index being at 1 instead? So if this started at k equals 7, you'd be missing k equals 1 to k equals 6. So you'd have 6 less terms than the number up top here. Okay? So this section will take quite a bit of practice for getting comfortable with these formulas, figuring out what formula I use and what piece of information is pertinent where, but you'll get the hang of it the more and more you practice.